Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, and Korea. This webinar will run 30 to 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your GoToWebinar control panel. We will attempt to answer all questions at the end. If you're having technical difficulties, you can contact us the same way or call us at 410-935-6053. That's 410-935-6053. And we will try to resolve the issue quickly. Today's webinar is being presented by Jim Reed and Mansi Bundiwad. Jim is manager of MET's Meter Accuracy Lab. Mansi is regulatory NEB's EMC supervisor for MET. At this point, I will hand over the presentation to Jim.
Thank you. Hello, everyone. As was just mentioned, we are going to go over an ANSI Watthour meter testing and certification program. This is designed to help those who may or may not already be selling meters in the U.S. To become familiar with not only the requirements for entering the U.S. market with either watt-hour, revenue generation watt-hour meters or sub-metering, but also become familiar with MET's internal requirements and the program we have set up for certification to help gain access to that market.
Just click on the
Okay, just quickly, I wanted to go over some of the accreditations and recognitions that we have here at MET Laboratories. We are HLA accredited for testing to the ANSI C12.1 and C12.20 requirements for meters, for electricity metering. We are also the first nationally recognized testing laboratory in the U.S. for product safety evaluations, product safety listings, and recognitions. MET is also the only laboratory at this stage that is recognized by Measurement Canada, whereby they will actually recognize our test results for any meters that have been previously approved by Measurement Canada and have been modified in some manner. MET is also a telecommunications certification body for EMC and telecom. We are a certification body, a CB, for the Standards Council of Canada. Again, primarily the product safety evaluations involved there. We're a recognized test facility by Industry Canada for both EMC and telecom. And we are recognized in Maryland and New York by the Public Service Commissions for sub-metering as a test laboratory for sub-metering products. And here again is just a few other accreditations we have, and the various lab makeups, product safety, environmental simulation, the ENC electromagnetic compatibility lab. We also have a wireless laboratory as well as telecommunications and metering. Okay, so getting down into the details of the requirements for ANSI, Here, basically, there are 38 tests that are required by the ANSI C12.1 or the C12.20 standard for electricity meters. And the primary difference there between C12.1 and C12.20, C12.1 is for meters that are basically 1% accuracy or higher, and C12.20 contains requirements for meters that are 0.2% or 0.5% accurate. So it's a tighter accuracy there. And frankly, most of what we see anymore is tested to the C12.20 set of criteria because the revenue generation meters have a higher, tighter accuracy. But in terms of the tests that are required, they're very, very similar, if not identical, to the 38 tests that are shown here. So depending on the product that we would be testing, whether it be sub-metering or revenue generation metering, several, if not all of these tests may be required. So essentially what has to happen is you take a look at the product, what the features and functionality, intended installation of the product, and you determine from there which of these tests are applicable. It's also important to note that there are 8 tests here that you can see defined by an asterisk that are to be performed in series. So the standards define a set of series tests, meaning that a number of test specimens, a number of samples must go through these series tests sequentially. So you see test 15 is the first test there that's noted with the asterisk. That's the first test that we would perform on a group of meters that we would say were series meters. So we would take that group of test samples and run each sample through each of those series tests. And they must continue to comply from start to finish through all 8 of those tests. The other tests that would be applicable would not need to go through in series. So you have flexibility there in terms of testing to have different serial numbers going through different tests. And then you just have to make sure that you are testing the proper quantity of test samples to be compliant with the standard. So that's these are the tests that make up the ANSI set of requirements. Now getting into our MET meter certification. MET has been in the business of testing meters for a number of years. And with the smart grid coming online and smart meters, solid state meters becoming more common in the marketplace, we saw a need for developing a certification program that went a bit beyond what is simply required by the ANSI. Utilities and buyers of these electricity meters all want to see the ANSI set of criteria met, whatever is applicable. Typically, everything that's applicable would need to be tested before they would go ahead and purchase a product from a manufacturer. But it's a separation there of sorts between manufacturers that have been in the business for a while and have established relationships with utilities in certain regions, and those manufacturers that are trying to break into the marketplace. So really the MET meter certification program can be helpful to everyone, but it's most helpful probably for the new manufacturers, the manufacturers and trying to break into the marketplace and establish relationships with the utility. So the core requirements that we have for our meter certification program is, of course, we need to go ahead and test the required number of samples to the applicable test out of either ANSI C12.1 or 12.20 as appropriate. To those standards, there must be a certain minimum number of meter samples tested as you run down through all the applicable tests. And what it boils down to is a minimum of 3 meter samples need to be tested for each of the tests. Now again, we talked about the series test. If we were going through a test program, we would have to have 3 samples going through the series test. The identical serial numbers would have to go through those 8 tests that I mentioned earlier. But we could have additional samples available to run tests concurrently, run tests in parallel for some of the other applicable tests. And we would have the flexibility of trying to work to expedite a test program and get everything through the test program, test all the minimum number of samples of 3, but they wouldn't need to be the same serial numbers for the non-series set of tests. So, of course, we're doing this. We're giving a detailed test report at the end of the test program. That test report is going to have all of the details of the test in there. We're going to be looking at detailing the number of meter samples that were tested, the serial numbers of those samples, the FCC ID or the identification of the AMR or AMI module that are installed in those meter products, what the test configurations were going into the test program, any details per test, how the meters were set up and how they were tested, photos, all of the details are going to be in the detailed test report. Now that in and of itself, those 3 bullet points there, that doesn't differentiate from any other test program. If we have a customer coming to us saying, we just want to test our meter, we don't need net meter certification, well, that's what you would get. You would get, of course, all of the applicable tests addressed. You would have the minimum number of samples or more going through each of the tests, depending on what the test program entailed, and you would get a detailed test report. Now, the meter certification program goes beyond that, again, to help people get into the marketplace, to sort of broaden their market base. We will maintain the database of certified meter products. We maintain it here on our network internally with all of the details of the test and the meters that we were certifying. And we also will list those meters and the model numbers on our website in a place on our website that will detail which meters have been certified by MET, so that you have some exposure there in terms of your potential buyers being able to get onto our website and see that, yes, your meters actually are on that list. And beyond that, MET will coordinate with the manufacturer to help them through any potential compliance issues based on modifications that are done to the product over the course of the product lifetime. So obviously, there are always changes happening. You have a product that was tested today, but now 3 months from now, 6 months from now, there are going to be changes. Perhaps a part cannot be sourced from the same manufacturer as was installed in the meter when you originally tested it. Perhaps there's another AMI wireless card that you want to install in the meter. Firmware changes. There's a myriad of changes and modifications that can happen over the course of a product's life. And MET will communicate, and there's a dialogue that's established between MET and our customer to talk about what the modifications to the product are, and we will be able to sit down and with the folks here in the labs and determine, will those changes affect compliance? Many times they won't. Sometimes they do affect previous compliance. If we feel that compliance may be affected, it's probably only going to be certain tests that could come into question depending on that modification, but really it's a case-by-case basis. But the point is we're staying on top of it, and we would pull product in, the modified product, and run through only those tests that could be affected by those modifications. Beyond that, there's an annual continuing compliance program where if nothing's changed with the product, at the very least we would bring it in just for a quick accuracy check and kind of keep the check and balance going to make sure that, okay, the product does continue to comply with the accuracy portion of the standard for full load, light load, power factor testing. So sort of a baseline minimum accuracy check. And all this, again, is for marketing and to try to have the manufacturer assure their buyers that they're staying on top of compliance. It wasn't just a one-time thing where you submit the product, it went through a test program, it complied, now it's 9 months later, now it's a year later. Is it still the same product that went through the compliance program the first time around? With a MET meter certification program, you're going to assure that we are staying on top of the compliance issues. So those are the core requirements and the core program for MET meter certification. The accuracy acceptance testing, again, at a minimum, 3 samples are to be tested for each applicable test. There are 38 tests. Most of the time, all 38 tests do not need to be run through for any one particular product. So typically, it's a subset of that. Some tests are going to be not applicable, and we are going to address that in our detailed test report as well. It's not applicable because, and give the rationale as to why. Something so that when you submit this test report, this report of compliance from a third-party independent lab, it will show that everything was addressed, whether it was compliant, whether it was not applicable, the details of the setup, and so forth. Again, if the product has been modified, we're going to use engineering judgment to determine which tests need to be reperformed. It's easy to say, oh, okay, you've modified the product, you've got to go through all the testing again, and this will be applicable to that product. Well, obviously, that's going to be very costly to a manufacturer, and it doesn't make much sense to do it that way, to approach it that way. So with working with MET and us having previous experience with the product, we're going to be able to make an engineering judgment on what those changes could affect, what changes that would not affect any previous compliance, and work with the manufacturer to, if we need to retest, to put together a test program that makes sense for that modification and specifically addresses that modification with previous compliance kept in mind. And, you know, obviously the changes are a case-by-case basis. It really would depend on what's changed in terms of what might need to be retested for any particular product. Generally, we're seeing, again, updates with firmware, changing the communication modules, wireless modules, and parts changes where, you know, you're sourcing parts from a different manufacturer or a different type of part. These are the types of changes we see. Now, I'm not saying that everything would necessarily need to be, you know, communication established with us. Changing a resistor vendor or capacitor vendor, that's, you know, likely not going to be something we need to know about. But I would say, when in doubt, go ahead and ask the question. That's what we're here for. We can talk it through with you. Okay, some of the challenges and considerations when we're testing smart meters. The ANSI standards, the C12.1.20, were written for, I have basic meters here, but it was written for the meters themselves, the electricity meters and the accuracy of the meters themselves, and any environmental test, you know, trying to affect the accuracy of that meter. But they weren't, the standards were not written for smart meters that we see today. So when we get a product in, we need to be you know, cognizant of that and be smart about how we approach it and how we put together a test plan, so that not only are we testing and being making sure that the accuracy of the meter is there. But also we want to make sure that any effects of having a wireless module, for example, in the meter itself is not going to affect the results of the test. We want to make sure that we're adequately operating that wireless meter to the fullest extent, or to a reasonable extent anyway, to prove out that there's nothing going to be, no problems are going to be seen in the field, at least from a test lab perspective, and being able to simulate real-world environment from a test lab perspective. We're going to try to make assurances that there's nothing that's going to affect the accuracy of that product. So if you have, the AMI module installed, AMR module installed, we're going to make sure it's transmitting at full power, for example, to be sure that that doesn't affect communications, just as an example. Now, in order to do that, we're going to need support equipment for these test programs. So we're going to have use typically a notebook computer with software running to be able to communicate with the meter itself. We may need to configure it properly. We're going to need to actuate any disconnect switches if those switches are in the meter under test. And again, assure that communication is established and that we can see not only the meter being accurate, but you really want to see that when you pull the meter through the wireless module, it's also reporting the same register, and you don't have any issues there. Again, you want to try to tailor it. You may not be able to simulate all full real-world environments or situations, but you want to be reasonably sure that it's going to work properly. And that's what we're trying to do when we put a test program here. You want to make sure here in the lab that if there are any timing periods for booting up, starting up the meter, are there any diagnostics that are happening, communication between the meter and the wireless module, for example. Many times we'll see that be an issue where, okay, we've got a test board, we are connected to that, looking optically at a test bus, and that communication many times may interrupt or may make it appear to our test equipment that the meter is pulsing, which could throw accuracy off. So we have to be aware of this type of communication. Don't always see that, but sometimes it is a boot up period that we need to be aware of there. I mentioned before the wireless communication modules. You need to make sure that they're tested at full output power to be sure that that's not going to affect accuracy. There are times when we've seen a module that's not set to transmit at full power not affect the meter's accuracy. However, when we set it to full power output, it can affect the accuracy. So we just want to make sure that when we run through our test program, it's a valid program and we've covered those bases. And I mentioned some of the communications issues that we see on the optical ports. Again, that if you have communication on that same test port that we're using to measure the KT pulsing, then we can essentially fool our test equipment into thinking that it's pulsing rather than just simply communication between the module and the meter. That's going to throw the accuracy off tremendously. So in general, some of the conditions that we see that would affect accuracy, here I would say that there are two sets of tests, if you will. There's a group of accuracy related tests. Essentially, when you look at the standard, test number 1 through 14 is really the core of the accuracy tests out of the standard. Tests 15 through 38 are really external influences, environmental influences, radiated immunity influences. These are different influences that the product is going to see out in the field. They could affect accuracy. So based on that, we have temperature and humidity cycling that's performed in the standard. There's a an ambient temperature test where you're looking at accuracy in unity power factor and 0.5 lagging power factor. That'll run from ambient temperature up to 50 degrees C and down to minus 20 degrees C. There are operating temperature tests and relative humidity tests that'll go beyond that, where you want to make sure that the product can operate between plus 70 to minus 30 degrees C, and also operate at 85 degrees C at 95% relative humidity. So occasionally we do see where meters will, at some of those peak temperatures, high or low, will simply stop working. So these, again, these external influences, the environmental aspects of the test would affect the accuracy. Occasionally noise that's created by the wireless modules that may be installed in the product could potentially affect the accuracy. There are fault tests that are performed for current faults under test number 20, where you could also see problems there. These are probably some of the more problematic areas that we see from the environmental and the electrical side of things. And I will say that, as was sort of alluded to earlier, there are two different labs that handle our test program here. We have the meter accuracy lab, and that's my group, and we also handle the environmental tests as well. And then we've got Monsi's group that handles the EMC test. So as I'm going through these, I'm really speaking from the accuracy and the environmental perspective. I'm going to go ahead and let Monsi speak toward the EMC-related tests here in a moment. Let's see, just a little bit more of the wireless modules. Again, you need to transmit at full power. When they are at full power, sometimes we'll see problems there. Improper calibration of the meter at test amps. That's something that we'll see right away. That's very rare, but on occasion we'll get it in and run a quick pre-test performance check on a full load, light load power factor and see that it's actually not in specification right away. Of course, if that happens, we notify the manufacturer right away and get some other samples in here. Typically, it's some anomaly that's caused that. Harmonics, both voltage and current, could affect accuracy as well. I'll note that at this point, at this stage anyway, the ANSI standard does not affect any harmonics testing, does not include, I should say, any harmonics testing, but it looks like that's on the way. We are on the ANSI committee, and we attend the ANSI meetings for the electricity metering, and it looks like at some point in the future there will be harmonics tests included in the standard, along with some other issues. And again, it's really prompted by seeing problems in the field, and utilities are involved and manufacturers are involved, and they see these problems and they get written into the standards to help clear those types of issues out before products hit the market. Again, some more of the common test failures here. Everything, any of the 38 tests in the standard could obviously affect the product and could cause a failure. But again, the temperature, the operating temperature, the humidity test, many times we'll see that be a problem. And typically it's at the high points of that, at plus 70 or maybe plus 85 with 90% humidity, or at the low end at minus 30. Accuracy problems under power factor conditions could be an issue. The performance for accuracy under the full range of tests, not just at test amps or at light load, but light load up to the maximum current that the meter is spec to, could be an issue. The disconnect switches, lots of times we'll see issues with that. Although the manufacturers there of the disconnect switches do seem to be getting better, but the problems we'll see is typically welding shut of the contactors, where we can no longer actuate that disconnect switch after the 7,000 amp peak test, which is a test where you've got to continue to operate both before and after those tests. We'll see sometimes welding with contact there, or even some fragmentation. There's also another part of that overcurrent testing that goes beyond. It's more of a hazardous test. But there you're looking to make sure that the product fails safely. But in terms of failures, most of the time you're going to see that failure occur at the lower current where it doesn't actuate that disconnect any longer. Metering losses, again, I mentioned that the standards were written for to address the meters only. Now that the meters have wireless modules installed, many times the meter loss testing will not comply because of the additional load draw due to those AMI modules installed. Circuit cards, connectors, standoffs becoming broken during the transportation vibration or drop test. It's important to note there that really, if we see that, we will mention it, because the standard is not looking to call something like that a failure for those drop tests, for example. The pass-fail criteria there is that it's got to remain accurate. So essentially, we do a performance check both before and after these tests. Many times we'll see a cracked standoff or a connector that comes loose that doesn't affect the accuracy of the product in that condition. Then we call it a compliant. Of course, we're notifying the manufacturer of that because many times they want to address the issue. But just because something would crack, for example, doesn't necessarily mean during the drop test that it's a failure. So it really is dependent upon what the pass-fail criteria is out of the ANSI standard. Weather simulations tests are done for simulating UV and rain events or spraying events that are performed on the meter, and there we see occasionally discoloration of displays, discoloration of the domes, or even the plastic facing of the meter. Those are non-compliances. There's also rain tightness tests where occasionally we'll see ingress of rain, ingress of water into the enclosure of the product itself. So again, from the perspective of the accuracy in the environmental lab tests, these are some of the more common failures. And I'm going to go ahead and pass it over to Monty and let her speak a bit about the more EMC-specific tests that are also in the standard. Monty?
Thanks, Jim. Hello, everyone. My name is Monty, and I'll be discussing, or I'll be talking about the EMC aspects of meter testing and certification. So let's talk about what tests are included under the EMC portion in the ANSI C12 standard. Now, test number 16 to test number 28 are some of the tests that are related to EMC, or the electromagnetic compatibility lab. And let's look at what each of these tests entails briefly. Test number 16 is voltage interruptions. Now, voltage interruptions are caused because of faults in the network or when there is a sudden large change in the load. Test number 17 is effect of high voltage line surges. Now, this test is performed to determine the surge withstand capability of an equipment that will be exposed to known or unknown surge environments. Now, the major concern here is either switching induced or lightning induced type of transients, which will give rise to either a ring wave or a combination wave pattern. This test is usually performed at 6,000 volts or 6 kilovolts. The next test is test number 18, effect of external magnetic field. Now, when there is a strong external magnetic field on a current transformer or a pulse transformer, the current transformer or pulse transformer will saturate, and the output will be less than proportional to the input that is being applied. Now, this will obviously result in a revenue loss to the utility company. The intent here is to subject the metering device to an external field and then monitor the change in the performance. Then there is test number 21, effect of current surge in ground conductors. Now, this test subjects the meter to very strong magnetic impulses, which somewhat simulates the effect of an indirect lightning discharge. Then there's test number 25, electrical fast transients. Now these are the repetitive electrical transients or disturbances that originate due to switching transients or inductive loads. Then test number 25A is the effect of electrical oscillatory surge withstand capability, or SWC. Now this test is intended to verify the immunity of relays and relay system to repetitive electrical transients. Now this transient is a damped oscillatory wave which has an amplitude of about 2500 volts or 2.5 kV, and this is just the amplitude of the first peak. The frequency of this transient is typically 1 megahertz. Then there's test number 26, effect of radio frequency interference. Now this test verifies the immunity of the metering device when they are in close proximity of intentional radiators, say walkie-talkie or cell phones. Test number 27 is radio frequency conducted and radiated emissions. Now this test, or the intent of this test, is to make sure that the emissions that are coming from the metering device, they meet the limits that are imposed upon by FCC Part 15B for a Class B type of device or a residential device. Then there is test number 28, electrostatic discharge, which verifies the immunity of your equipment when it is subjected to the static electric discharges, typically from operators. Okay. Now most of these EMC tests that we just discussed, they refer to some common national or international standards for the test methods and test procedures. So for example, if we take the ESD test, the test methods and the test procedures for this test are described in IEC 61000-4-2. Then the emissions test methods are described under, the limits are given in FCC Part 15, whereas the test methods and procedures are described under ANSI 63.4. So basically, what it does is, this reference to other standards for test methods and procedures, it allows for the repeatability of test results between labs, and it also provides a standard method of testing. Now there are two tests on the scope, within the scope that we just described. This is again just the EMC related scope. Test number 18 and test number 21, which do not have any reference to any other international standards. So we just have to go by the procedure or whatever limited procedure has been described in the ANSI C12 document. Now let's look at test number 21 and test number 18, that is the effect of current surges in ground conductors and the effect of external magnetic field. Now as we just briefly mentioned, test number 21, what it does is it subjects the meters to very strong magnetic impulses, and it simulates the effect of an indirect lightning discharge that occurs in the vicinity of a ground rod. Now the wave shape is typically a bi-exponential current impulse. It has a very high magnitude of 20,000 amperes or 20 kiloamperes with a rise time of 20 microseconds and a half-life of 50 microseconds. Now this impulse shape is quite similar to a conventional surge impulse that comes under or is described under 61000-4-5, but the timing constraints are about 2.5 times longer. Now the strong magnetic impulse, it could severely impact the operation of a meter or even destroy it, which we see sometimes due to the very strong induction. Now the magnetic impulse, or inducer, if you will, it consists of a conductor that runs parallel at the back of the meter and is located very close to the meter at a distance of 1.5 inches. The next test is test number 18, effect of external magnetic field. Now, this test is done where the meter is subjected to an external magnetic field of 100 ampere turns, and the meter is placed at a distance of 10 inches from the center conductor of the coil that is producing this magnetic field. So the way this test is done is you create a field of 100 ampere turns, place the meter about 10 inches from the center conductor of the coil in various orientations, X, Y, and Z, and then you monitor the meter for any change in the performance when it is subjected to this external field. So when this test is being performed, you monitor for the accuracy as well as after the testing. You have to make sure that the accuracy equipment or accuracy measurement equipment that you are using, it is not affected by this external magnetic field. One other thing that you would also have to consider is make sure that the current is in phase with the voltage that is applied to the meter device and also to the coil that produces this field. Now, some of the common ANSI tests that we see failures for are test number 27, radio frequency conducted and radiated emissions, effect of high voltage line surges, electrical fast transients burst, radio frequency interference, and voltage interruption. Now, these are listed in the order that we see the most failures for. Test number 15, insulation test, although it doesn't typically fall under the ANSI test category, sometimes we also see some issues or failures with that test as well. So basically, pre-testing is a very quick way to identify any potential issues that may arise on these tests. As you might be aware, and as Jeff mentioned, the pass-fail criteria for ANSI are very stringent. So if you have a failure that occurs, say, during one of the series tests, then depending on the pass-fail criteria given in ANSI, and depending on the number of samples you're using, we may possibly have to redo all the testing from scratch. So pre-testing is a very effective and quick way to try and identify any potential problems that the metering device could face or could see. Now, just to wrap up some of the important test considerations for EMC. Now, most times, a meter add-on device manufacturer, they'll perform some quick pre-testing in-house before submitting the samples to a test lab for official testing. They may or may not have access to these international standards like 61000-4- standards, which call out for the specific test methods and test procedures. So it is possible that the way you perform this pre-testing, you may get some different results based on how you conducted the testing versus the testing that actually takes place in the lab. So it is important to make sure that you have the access to all the right standards and follow all the guidance that is provided therein. Some other considerations are make sure that when you submit your samples for testing, make sure that all the ports are properly cabled because, as you know, like cables act as antennas to radiate and receive radio frequency energy. Also pay particular attention to the cable length requirements that are called out in some of these standards when you submit these samples for testing. And one other thing to note is if you're doing some of this testing in-house, or if you're doing some pre-testing on your own for test number 18 and 21, just make sure that accuracy measurements, they are required during the test as well as after the test for these tests. Now, these tests can magnetize parts of the meter momentarily, but the meter will most likely return quickly to its original state. So these are some of the issues that you're most likely to encounter during the EMC portion of testing. Yeah, that's it. I'm going to hand over control back to Jim, and he's going to speak some more on accuracy.
Okay, thanks, Monty. So we were talking about the challenges, of course, in testing smart meters because the standard does not necessarily specifically have requirements for smart meters per se. It really was developed from the older electromechanical style revenue generation meters. But now everyone that has a metering product wants to go ahead and refer back to the ANSI C12 test requirements for any type of metering product, really. So we see all sorts of products that are not necessarily revenue generation meters that are required for testing, required by the buyers of that product or the potential buyers of that product. So there's no specific required mode of operation. I mean, you have such an array of different types of products anymore that we're trying to apply this standard to and try to prove that, okay, the accuracy is good to a certain percentage. It may be like a class 1, class 2 type accuracy, 1%, 2%, or it may be a tighter accuracy in the 0.5% range. No matter what, we're trying to formulate test programs around that product and apply the ANSI requirements to it. We're very successful in doing that. It's, of course, been very successful and benefited our customers greatly. But it is a challenge to do in many cases, and there's no one magic answer for the mode of operation of any particular product. You just need to keep in mind that depending on how the product is to function, where it is to be installed, what the purpose of that product is, we want to form a test program, a solid test program around that product. So at the end of that program, when you have your report of compliance, you can pass that over to your potential buyer, and it carries weight. It is not something that looks like we're skirting around certain issues. All the bases are covered, so to speak, and that product has been fully tested, and that test program and the resulting test report really carries weight. It has real meaning to the potential buyer. Again, the ANSI C12 standards, they address the accuracy and the environmental issues and issues that could cause problems with the accuracy of the product. But there could be other, depending on the type of product it is or what is involved with the unit itself. If it's got the wireless communication modules installed, for example, there may be other standards that need to be addressed beyond the ANSI and the accuracy piece of it. So, for example, the FCC has requirements and certifications that address those communication modules. So the modules that you're using or possibly developing on your own need to go through those certifications as well. Again, that's something that MET can certainly help you with. We've got our wireless test lab here, and we can help guide you through that process as well. And at the very least, make sure that the product, if you're purchasing it off the shelf, for example, has met those criteria. Also, the utilities and even manufacturers sometimes have additional tests that they want to see addressed that go well beyond the ANSI standards. Again, not everything is in the C12 standards, and there are a lot of problems that will arise in the field, and unfortunately, many times that's after a certain number of products have been deployed, and you start seeing some reoccurring events and problems. And during the course of a test program, you may want to extend, for example, a MET certification program to address some of these other issues that you're seeing in the field. And certainly, so the MET certification program, it's a very flexible program. It's not rigid. It's only rigid in the fact that you need to, of course, test to all the ANSI requirements because, of course, that's what everyone is asking for. And you need to meet certain criteria in order to become certified, quote unquote, at MET laboratories. But beyond that, there are also optional tests that can be performed. Again, with the utilities, we perform side-by-side testing. There are transient tests that are performed on the meters, and quick transients and dropouts that are not in the ANSI standard. But again, seeing some issues and reoccurring events in the field, many times some of these come to light, and you want to try to recreate that in the lab, and we can certainly help you out there. So some of the optional testing that can be either tagged along with or even separate from a meter certification program doesn't necessarily have to be tied directly into the meter certification program, but you may want to get into some other areas, the product safety certification, the product and listing. We have HALT, HAS for life cycle testing of products, factory inspections for any QA type issues that you may have concerns with either in your own manufacturing facility or in a supplier's facility for that matter. Production sampling program, you may want to set something up where you're setting aside a certain number of samples right off the production line to shoot them over to MET and have some performance checks done on those, maybe some other tests, susceptibility testing or emissions testing, what have you, whatever your concerns are. Again, the program is flexible, and we're certainly able to cover a wide girth of different types of testing here at MET. Or utility-defined requirements. Many times, remember, ANSI gets you in the door, particularly if you don't necessarily have a relationship with your buyer up front. There may be, ANSI is going to get your foot in the door, but it may not be the cure-all. It may not be the full answer. There may be other concerns that your buyer has where he says, okay, great, I see you have the ANSI testing here. Things look good. We'd like you to try this just in case because they've seen something in the field. So, you know, speak with us about that, talk it through. We can probably certainly come up with a, again, a test program that will simulate some of these events that would be a concern to your buyer or the utility or wherever your target market is, really. So the getting into the details, I would just sort of quickly, the product safety certification or the listing, OSHA approved testing to UL 61010 for metering products. Not necessarily a requirement in all jurisdictions, however your buyer may request it of you, may require it of you. In these cases, a listing is going to be like any other product safety listing, 60950, for example, where not only are we evaluating the product and giving you a MET mark, allowing you to mark your product as listed by MET Laboratories, but it would involve follow-up inspections to make sure quality is in process and there available at the manufacturing facility. Things are up to snuff there in terms of what is required for that product listing. HALT HAS is another one that we see occasionally. Folks will come to us and they want to say, okay, we're going to buy these meters. How can you tell us that they're going to be okay for 20 years in the field? Well, we really can't say that. But what we can do is offer a HALT program, a highly accelerated life testing program, where you really get to a point where you harden the product through the process. Just in a nutshell, it's really you're trying to break the unit, make fixes to harden the product, to make it more ruggedized, more resilient, and move on. So, that program is not going to assure you that this meter, for example, on the side of a home is going to be there for 15 or 20 years like the old electromechanicals were. But it will give you a high sense of assurance that it is a reliable product at the end of that program. Because, again, you're really trying to break it, fix it, break it, fix it to the point where it really comes out of that test program as a ruggedized product. The HAS testing, the highly accelerated stress screening, is more for production type samples. There may be some tests that we can put together there for you where you can pull production samples, give it to us. It's not as expensive as a HALT program, but it does assure that the products that are rolling off your production line meet a certain level of criteria that that could prove that, okay, we're still a ruggedized product. Again, these types of programs are something you'd have to speak with our folks with and really nail down what you're looking for and what a good solid test program would be. And it could be highly beneficial, particularly as a marketing tool for trying to enter specific marketplaces. Okay, ongoing utility and development concerns. The problem areas, again, that we hear back, so feedback from utilities. They have issues with hardware in the field, failures. They can't understand why it's gone through the ANSI testing. Disconnect switches they have problems with many times. That's getting better, as I mentioned earlier, but we still hear about that sort of thing. Communication modules, either failing to function in the field or causing problems with the meter itself or even other equipment nearby. Firmware updates, these sort of things that you wouldn't think on the surface of it would cause issues, and sometimes it does, or even installation methods. So these are some of the things that we hear back from the utilities, and we'll get products in here for testing, or maybe they may put that onus on the manufacturer to, hey, go take a look at this because we're seeing this in the field. Bottom line is we can help you there. Again, try to come up with something that in the laboratory environment simulates that real-life world and those effects, and try to nail down exactly what's happening there. Those type of tests are always experimental in nature, and it's open to interpretation on how to apply that sort of thing. So again, just with communication and trying to put together a program that makes sense and trying to nail down what might be happening in the field. It's a moving target sometimes, but we can help you out there if you run into those types of situations. And of course, there's always differences of opinion on how to perform the test. I mean, from lab to lab, and manufacturer to manufacturer, utility to utility, because of the all standards are open to interpretation. Most of the standards that I've written, it's always a certain degree of interpretation that can be taken by one or the other that may differ. So, having everything tested at one lab does certainly help, I believe, in keeping continuity there and the same type of interpretation. And we can certainly speak with you and talk that out. Okay. So that pretty much sums it up, other than the benefits of the meter certification. It ensures that all the meters are consistently subjected to the appropriate standards and requirements. We do this all the time. We've done it for a number of years. We know what the requirements are and the standards that need to be met. We're monitoring, again, the product changes that could be huge, especially for folks that are sort of new to the field or trying to break into maybe a different market segment or a different region of the country where you don't necessarily have that rapport built up with these folks. You're showing that, okay, not only did the product pass last year this time, but it's also, the changes that we've made, we're communicating with the third-party laboratory, and we've come up with some of these additional test-approved compliance. That can go a long way. That's huge. Third-party unbiased evaluation, it speaks for itself. There, it's not the manufacturer just saying it's okay. So that for your buyer is also big. You've got somebody that's separated from your organization, that third party that's doing the evaluation and saying, yes, this is compliant. And not only is it a third party, but it's well known in the industry. So we've got folks here that, of course, stay abreast of the standards and the complexity of the standard, and also, again, the concerns in the field with the utilities and what we hear that aren't even addressed, some issues that aren't even necessarily directly addressed in the standards. We have this knowledge base here that you can lean on. So, I guess the bottom line is when in doubt, ask the question, use us as a sounding board. That's what we're here for, to try to help you out, help you sell products. We've been in the business of testing meters for over 40 years, in one form or another anyway. We're the only lab, to my knowledge anyhow, that has a certification program like this. We've visited with public service commissions. We've visited with utilities. We're on the ANSI board for developing these standards. So we keep in touch, keep our ear to the ground in the industry. Again, the flexibility of a customized program. You've got your baseline requirements, your MET meter certification. And, I mentioned it early on. If MET meter certification isn't the thing, you really aren't concerned with any of the changes, well, that's fine, too. Of course, we can do all of the testing, and we do it all here in one laboratory. We're not subcontracting it out. We're not doing it at multiple locations. If you wanted to witness, you can certainly come in and witness some, particularly if you have issues with any certain type of test. More than welcome to do that. We do it all the time, every day. We've got the searchable meter database that's accessible through our website online. So again, it could be a tool for you to market the meter. We're trying to get some rapport built up with a buyer and let them know, hey, this is on a MET's database. They can go look for it themselves and see that it is there. Again, the industry recognition I mentioned earlier, we're customer service oriented. We want to make sure that you're going to be successful with the product. And, in general, this MET is a gateway to measurement. Canada and Mexico's CFP set of criteria, which is very similar to the ANSI set of criteria as well, certainly demanded by Mexico and their federal authority there. Okay, so that wraps it up. That's our contact information. And I'll go ahead and pass it back over to Barnaby. And thank you for your attention.
Yeah, thanks, Jim. That concludes the presentation portion of this webinar. This presentation will be available on metlabs.com, and we will be sending a link via email to everyone who's registered for this webinar in the next day or two. Now, real quick, we will answer questions. If you have a question, please type it in the questions area of your control panel. We have a couple questions already. Please give us a 10 to 15 seconds here to get started on answering these questions.
Yeah, so we have a question that come in just now. What is the C12.16 standard? C12.16 is an older standard, and we do hear that requested occasionally. Really what that is an older version of C12.1 with all the criteria there. So that standard is no longer in force. So essentially, if you have somebody that's requesting C12.16, what you need to prove out is that you've tested the C12.1. It's the same set of criteria, really. It's as I said, an older standard that's no longer in force. It's C12.1 that would really take the place of that. Do the series testing in C12.1 have to start with test 15, then continue to test 16, and so forth, or could you continue with the same 3 units in the series test in any order? And the interpretation there is no. Basically, you have to go sequentially through those tests in order. So we start at 15, run to 16, and so forth, and we end with test 30 and 31 with that same set of meters. And again, those meters need to be compliant all the way through. Now, there are some provisions in the standard where if you have larger sample lots, that you can have a failure along the way, but really that I can tell you from experience that doesn't look very good at testing for saying that something failed. So typically you would want to go with 3 units, and it's more costly because obviously if we're testing 3 units for a test, that's going to be cheaper to you going through a test program rather than us testing 6 or 9 samples for that same test. And I really only say that as a side because this question addressed 3 units, and I was talking about 3 units earlier. So basically what you want to prove out is take that minimum of 3 samples, have to go through every test and go through it. But in terms of the series test, we do need to start out with 15 and roll through until we hit test 30 and 31. Another question, in general, with meters that use external CTs, is the testing done only on the meter, or is it, does it need to be done on the CTs as well? Well, because the CTs are part of the metering product, we do need to test with the CTs, with those external CTs. So if you have, we see this with sub-metering a lot, where they'll have their meter product has the ability to have really any, within specifications, any off-the-shelf CT that could be used with that product. The problem is that creates such a broad number of products that need to be tested that when we run our test program through, we need to prove that we tested the unit and we specify what type of CT was used. I know the CTs are qualified separately, but really your buyer is going to want to see that the product was tested with a specific CT. And certainly our test report is only going to detail the CTs that were tested and found compliant in our laboratory. So what we'd like to have our customers do is narrow down a wide variety of CTs to 1, 2, 3, and we'll roll through that way, testing with the CTs that you're really targeting to sell with your equipment. But they do need to go through the testing programs. And there's an aside there, is test number 20 is the effective temporary overload required for the meters that use CTs. And the answer to that is no. The test number 20 for that temporary overload, where you get 7,000 amps peak running through the product in a fault condition and 10 or 12,000 amps RMS running through, we're simulating that in the lab. But because the CT is external to the product, we're really running that test only on self-contained meter products. So if you have a product with external CTs, we're going to call that not applicable for a typical test program.
Thanks, Jim. If there are any other questions, please contact Jim or Monsi directly. In the next day or two, we will send a follow-up email that will include a link to this presentation. That concludes our webinar. Thank you for joining us today.